Hey there, this is the second video about how HTTPS works, and today I will explain how HTTPS helps client to make sure that it is connected to a real server. In the previous video, I talked about how a symmetric pair of keys is used to safely exchange a shared session key to secure the communication between a client and a server. Now, imagine that a bad actor, instead of trying to steal the data, actually intercepts the whole communication and pretends to be a real server. It can have its own asymmetric pair of the keys, which can be used to exchange the shared session key and then start the communication as if the client talks to the actual server. As long as the bad actor is able to mimic the server behavior well, client may send some vulnerable information assuming it is safe. Fortunately, HTTPS protects client from that kind of attack as well. As you may remember from my previous video, in the beginning of the shared session key exchange, after the client established a connection to the server sends its public key to the client. The truth is that the server sends to the client not just a server public key, but a so-called SSL certificate. And server public key is just one piece of the data within that certificate. Beside the public key, the certificate has information about who is the issuer of the certificate, to whom it was issued, and when it will expire. It also has the certificate digital signature, which makes it impossible to forge any bit of the information within the certificate or fake who is the issuer of that certificate. When client receives that certificate, it verifies it. It verifies the digital signature, the organization which issued the certificate, whether the server mentioned in the certificate is the one the client is trying to connect to, and whether the certificate is up to date. If everything is alright, it uses the public key from the certificate and continues to the shared key exchange flow as we went through in details in the previous video. It generates the shared session key, it encrypts and sends it to the server, where it gets decrypted, and the session key exchange is successfully completed. Now let's see what would happen if there was a bad actor intercepting the communication and pretending to be the server. Even though the server certificate is publicly available, it cannot be used by the bad actor and sent to the client as is, since it has the public key of the server which works only with the server's private key. So the bad actor needs to have its own certificate with its own public key in it, which would work with its own private key. Now, after client established the connection to the bad actor, assuming it is an actual server, the bad actor sends back its own certificate, and client starts verifying it. There are a few ways how the bad actor could try to fool the client with a fake certificate. The simplest and most straightforward way would be just to get the real server certificate and replace the server public key within it with the bad actor's public key. Client would see that the issuer is the trusted organization. The certificate was issued to the server which the client tries to connect to. The certificate is up to date, but since the public key was forged, the signature verification will fail, and client will refuse the connection. Another way the bad actor might try to trick the client is by actually getting a valid certificate from the organization trusted by the client. The organization will issue the valid certificate, but within the certificate it will indicate that it was issued to the bad actor, not necessarily even knowing that the actor is bad. In that case, client will see that the certificate is issued by the trusted organization, the certificate is up to date, the signature is valid, but the certificate was not issued to the server which the client tries to connect to, and hence will refuse to continue. One more way the bad actor might try to fake the certificate is to generate and self-sign the certificate by him or herself. Unfortunately for the bad actor, in that case they would need to put their name as an issuer. Now, client will confirm that the certificate was issued to the server which the client tries to connect to, the certificate is up to date, the signature is valid, but the certificate issuer is not the one who the client trusts, and connection will be refused again. Now you may wonder why in this case the bad actor couldn't just put trusted organization name as the issuer of the certificate. That's a great question. And the simple answer is that it's technically impossible to create a valid digital signature without revealing who created that certificate. If short answer doesn't satisfy you, then watch my next video about how digital signature works. And for now, thanks for watching. If you found this video useful, press like, subscribe, and I hope to see you again.